Can you build a scalable and cost-effective API without managing servers? What if I told you that with AWS Lambda and DynamoDB, you can build a REST API that will scale without a lot of effort and that you will pay based on what you use? In this video, I will show you how to do exactly that using .NET. We'll build an API using AWS Lambda that will be writing data into DynamoDB, and we'll do all of that in just a few minutes. So let's dive in. But first, let's talk about why we are using AWS Lambda and DynamoDB. AWS Lambda is serverless computation. If you are familiar with Azure services, an AWS Lambda is basically an Azure function. This is not a sponsored video, so I can't say this type of things. So you write your code and you say to AWS, please run this thing. Do you need to scale it? Please do it for me. And you don't worry about that. You are just concerned about the code. And that code, you will say to AWS, please run it when a given event happens. For example, do I have a message on a given queue? Someone has written data into a given place. Or I can have an HTTP event. So if someone performs an HTTP request, that will be our event, the event that will trigger the code inside of the AWS Lambda. And what about DynamoDB? DynamoDB is a NoSQL database designed for scale. It's fully managed, and if you need to build high-performing applications, it's a perfect database, I have to say. And once again, if you want to compare with Azure, you can say that DynamoDB is for AWS what Cosmos DB is for Azure. The same idea. And the cool thing is that AWS is quite friendly for a .NET developer, and that is what I will show you. But let me be clear, while we'll be using .NET, you can do this with a lot of different languages. So the first thing that we need is tooling. So let's go and download the AWS command line interface, AWS CLI. Download the installer for your operating system, go through the wizard, and install it. Once the installation is finished, just close that window, go to your terminal, and now run the following command, AWS configure. And that will ask for the AWS access key ID. So we need to grab that from somewhere. So let's go to the console, that is this portal for AWS. And once you are there, go to the menu on the left, all services, look for this option, the IAM right here. Go into there, and there on the right, you will find these quick links with the My Security credentials. Get into those, and here you can see the access keys. So let's create a new one, and this will tell you that you shouldn't do this in the root user. So when you log into the console, it will ask you if you want to get in with the root user or with an IAM user, or role. So here I'm using the root user. That means that I can't trim down the permissions that that user has. So if you are doing this not for a demo like this one, and you are doing it for a production scenario, make sure that you configure this for the IAM user, not user, but role. So IAM is the permission model for AWS. I will not get deep into that because it will be a long video, but that's the difference, okay? I'm using the root. It's kind of like the admin of this thing is the master of this account. And in a production environment, you shouldn't use that administration user for having access to the resources, for example. So in this case, I will do that. I will say, okay, I know what I'm doing. This is just a demo. And now I will copy my access key and paste it here. And also my secret, paste it as well. And now I will grab my region from here, from the top. You can see it on the navigation bar. Okay, and I don't care about this, so enter. So the next step is to go into the portal and create our DynamoDB. So for that, let's go there, click here on the left, for example. And if you go to the all services, you can see the complete offering from AWS. Let's look for Dynamo. And you can see it here under database. So DynamoDB. And what you'll do is that you'll say, I want to create a table, so a DynamoDB table. And now let's give a name to the table. One important thing, pay attention to the casing because that will be important once you start using this. So I'll create a products table. So what we'll be building is an API endpoint that you can call to create a new product. For example, we are building a product catalog. So now the next step is to define the partition key. The partition key is one of those things that is extremely important to define well. So depending on your scenario, you might need to use a different strategy to find your partition key, because the partition key will be used to understand how to spread data and how to scale this DynamoDB table. So for example, if you want unicity on the data that you are adding to your table, the partition key will play a part on it, because the data with the same partition key will stay together. Imagine that you are scaling that table, so that means that if the data is from the same partition with the same value on the partition key, it will stay together. So for example, if you have things that are related to a given user and the access pattern is always targeting the same user, the user might be a partition key, for example. If you have things like categories, product categories, that might be another partition key. But if you want to spread the data, okay, because one thing about partitions is that you don't want to have one partition that is huge and a ton of them that are quite small, okay? It's a good idea to have a good spread of the data for different partitions. So you need to think about that when designing your table model. So for example, if you define something like a product ID as partition key, you will have a ton of partitions that are quite small. So let's use the product ID just as an example for this demo case. But for example, if in our data we had something like the product category, imagine that you sell different types of products, it might make a lot of sense to use that as the category. For example, if you are a clothing store and you have different types of items, for example, you have shoes, you have shirts, you have jackets, you have accessories, all those things could be a category, and you would use the category as the partition key, for example. It depends on the data that you expect to have. There's a lot of factors involved. Once you have that, you say, I want to create the table, and you will see it will go through a different status, say that it's being created, and eventually you will see this green. So that means that we have our table in place. So next, what we need to do? We need to create our project, our AWS Lambda that will be writing data into this table. For that, let's go into our IDE, and I will be using Rider, but you can do it with a different IDE. And you can go and install the tooling available for your IDE. There's extensions for VS Code, for Visual Studio, but I will not be doing that. I will do it without any of those tools in place. So for that, what I will do, I will create a new project that will be a simple class library, and I will call it Product API, for example. Pick the target framework that you want to use and create the project. So this is a simple class library without anything. And now let's start bringing things in place. Next, let's install a few packages. Let's bring the AWS SDK for DynamoDB, the Amazon Lambda core for creating Lambdas, the Amazon Lambda API gateway events. Why? Because we want to react to an API call. So that's why we are using API gateway. So let's rename our class to function. And that function needs a method that will be the execution of the function. So we'll name that method as the function handler. And we'll say that we want to receive an API proxy request. And then we say that we want to reply with the API gateway proxy response. So request response, a quite famous approach. So I'm saying, okay, let's write this to somewhere, and I will return this response saying that this was a 200 okay, and I can write here the message that will be in the body. So let's do something as simple as saying, okay, product was added successfully. Now I want to go to my terminal and package this Lambda to deploy it. Even without a lot of code inside, I just want to show you how to deploy this thing. So one way to do it is by doing with the terminal. Okay, we can use a tool to package this Lambda and send it to the place where we want. But for that, we need a .NET tool. So you can use the command .NET tool install and install with a -G for globally the amazon.lambda.tools. Once you have that, now we can run the .NET Lambda package. So this means that now the code was compiled. There was the restore, there was the build, and the tool picked the DLLs and packaged them into a zip file that will be a published archive that we can send to AWS. And how can we do that? We can run the command .NET Lambda deploy function and give a name to the function. So product API function. Now it will ask you a few questions. For example, what's the .NET runtime? I will say .NET 8. Give a name to a new IAM role. I will name it product API, for example. It will show you a list of the IAM policies that you can attach to that role in order to give permissions to it. So the one that I will use, you have here the full access. Obviously, don't use that in protection. But the one that I will use is this DynamoDB execution role because it has the right access. So I'll just type the number 5. You can set the memory size as well. I will set 256 megabytes. Keep in mind that this memory size can have impact in the pricing. So type the 256, not 256 MB. Okay, you don't need that part. Then you need to enter the timeout. So how many seconds should you wait until it timeouts the execution of that function? So let's say that is 60 seconds. And finally, is asking how to find the function itself. So the code that needs to be triggered. So for that, we need to set this type of namespace that we need to provide. So the assembly, the type, and the method. How do we know that? On this assembly, I have the function that is inside of the product API namespace. So you do, once again, product API dot function. Then you'd say the name of the method that is inside of that type. So paste it here, enter. And a new Lambda function was created. So let's go to the portal. And if we go now for Lambdas, we'll find here the product API function that we created. So since it doesn't do anything, we can simply go here and say, okay, let's run the test event, okay? The hello test event. We send anything, doesn't matter. So let's just click test. And we'll see that we'll have an exception. So it's saying that it can find the Lambda serializer attribute. Because basically now the Lambda needs to know how to pick the request data coming in and translate it into the thing that we are expecting. So we can do that in a quite simple way. We go back into our code and we go to the manage packages and we'll install the Amazon Lambda serialization system text JSON to use the system text serialization. Install that. And now in your function, let's bring an attribute that says assembly Lambda serializer. Let's use this type for the serialization. So if we have this and we once again run the package and then we redeploy it, now we can go back into the portal and let's test it again. So this time we executed it. It went well, we got a success, and we can see here in the response the status code that we provided and the body that we are returning. So the next thing that we need to do is quite simple. Now we need to write data into Dynamo. So for that, first we need to have our product. So let's bring here a class that will be our product. So the product ID, the name, and the price. So product ID will be our partition key, as we have seen before. So this class will act as the DTO that we are expecting. So if we go into this request, you can see the body. The body is a string. So we need to deserialize it into this class, okay? How can we do it? Quite simple. Call the serialization function and convert the body into that product. Now we can validate, for example, if the product is null, let's return an error, okay, a 400 saying that this is invalid, okay? So you can still have here different types of responses with different types of status codes. Once we have that, what we want to do here is to save it to the database, to our table. So the idea is simple. You write to a table, you say, put this item there, and you provide the item. To that item, let's call it a document. So we need to have the table, but let's create it as a field of our function. So in our function, we can bring a table, a field table, that we can use a table builder to build that table. The table builder will need an Amazon DynamoDB client. Okay, we'll get there in a moment. Then we say the name of the table. Keep in mind, this thing is case sensitive. And then we say the hash key. The hash key is the attribute that you have set on the partition key. So that's why I'm setting the product ID. With that, what we need the client. So let's bring a field for that. And to create the client, what we need to set the access key, the secret key, as we have seen before, and we need to set the region. So since these fields are static read-only, let's rename them. And now we can call the field to put the item there. To those items, we call them documents. Okay, that's why I have this document here. Now we need to create a document. The document can be created with something as simple as this. Because as you can see, if you hover here on the document is basically a dictionary. So we can say, okay, for the product ID, I want to set this value from the document that I deserialized. So I can say that, for example, for the property document ID, I want to use this property from this object, okay? You map those two, and then we can send it to the put async. This means that if it goes through, we can clearly say, okay, the product was added successfully. This is more than enough to pick that request, map it to an object, and send it into DynamoDB. And this way you can build a quite performant and scalable API. The only thing that is missing here to show you this working is to replace this access key and the secret key with the real values. There are several ways to do this, but for the sake of the demo, I will quickly use the environment variables. So I don't need to paste here the access key and the secret key. Okay, so that means that I can go into the portal, and if you go to the tab configuration, you can find here the environment variables. Then we can paste here the key and the value, add another environment variable, secret key, and this one I will not show you, and save it. So now let's go back into the IDE, rerun the .NET Lambda package, and run the deploy. Go back into there, go to the testing. Let's bring a new event, create a product. And now let's do the following. Let's go into these templates and use the one for the HTTP API for the API gateway. That is the one that we are using. And notice that you can set here all those things that can come from an HTTP request. Okay, you have things for headers, for query string parameters, all of that. The one that we want is the body, but the body needs to be a string. That means that if we remove all these things because we'll not need them, we want to provide a JSON there. But on this test window, what we need to do is to set here the body, escaping all those characters that would make this not a string. So it would be basically this. So let's test it. Okay, and it will go through, it says 200. If we go down here, we can see the things that we are writing to the console. So they are visible in the log output coming from the CloudWatch. We can see how long did it took to execute, okay, here in the duration. And now the only thing that we need to do is to go into Dynamo tables, get into that table, and go to the explore items. And if we go into that table, we can see that product that we just created, the product ID, the name, and the price. Next thing that I want to do is to go into the function, go into the configuration tab, and go into the function URL. There, you can create a new function URL. We can say the type of authentication. For example, I will say this is public, I don't want authentication, and let's create this. What this will do is that it will generate for you a function URL, so an endpoint that you can call to invoke this API. So we can use this, let's copy it, and in our project, let's bring a new file, api.http, and here, let's do a post to that endpoint and send the JSON. Let me use a different data and run the request. And we can see we got the product added successfully. And if we go into AWS, DynamoDB, explore the items, we can see that we have both of them now. And as you have noticed, we have called the API using a public endpoint. We don't need to do that thing of escaping our JSON. We can use JSON directly to call that API. And if you want to have a custom domain, for example, assigned to this endpoint, you can do those type of things. Why this approach is quite cool? One of the reasons is scalability. Not only scalability in terms of is this capable of scaling to handle millions of requests, but also scalability in terms of pricing. Because both offerings, Dynamo and Lambda, let you start for free. For example, Lambdas have, I think, 1 million requests that you can do per month, something like that. Yes, AWS Lambda has a free tier that includes 1 million free requests per month and 400,000 gigabytes per second of compute time per month. Okay, it's a lot. And Dynamo has a free tier that provides 25 gigabytes of storage with 25 write and 25 read capacity units. So the way that these type of databases are built usually is based on read and write units. So a unit is a metric that will be used to calculate how expensive was that write, how expensive was that read. Okay, according to them, if you look into the pricing page, it will say that it's kind of like capable of doing 200 million requests per month. What is a lot? And it's not only about the free things that you can take, it's also the fact that the price is based on what you use. So if you have a month that you have a lot of traffic, you will pay more than in one that things are quite calm. So you can see the power of this scalability and this approach with serverless technology, and those two go really well together. But let's be honest, this is not perfect for every single use case. There are some scenarios where using something like a Lambda to host our API is not ideal. And one of the typical problems is something like cold starts that can have a huge performance impact. The good news is that there are ways to deal with that, and I plan to have a video about that on my channel. So if you are interested on that, please leave a comment and subscribe to the channel to be sure that you are notified once I have that one out there. And now, in the meanwhile, I think you will like to watch this video right here, and I will see you in the next one.